Okay, good morning, everyone. Can you guys hear?
Yes, sir.
Okay, yeah. So I think Jarvis had told me you guys have a clash tomorrow with physics on Thursday. Yeah, is Jarvis not in here?
Yes, sir. We have a clash.
Okay, yeah. So do you guys want to move this class or are you going to move the physics class? What do you guys want to do about it?
Sir, we're actually looking to if the changes that you would make, because we also have another class as well with a different class, and the other lecturer said he would pick another time during our free time. So
All
I
right,
don't know.
so
Pick as well.
when are you guys free to have this class? Because I have class on Tuesday. I have two classes. Today I have one before this one. Friday I have a class. So yeah, maybe Monday or a different time Friday. When are you guys free? So we can schedule this class.
So we have Monday from 10 o'clock to 4 o'clock free, as well as Friday from 4 to 6 free.
4 to 6 free. Friday 4
You
to
all
6
set?
sounds too late. Monday could be good. Monday from when are you free? All day?
From 10 to about 4, and then we have another class after then.
Okay, so what time Monday? You guys think in the mornings or the afternoons?
Sir, we don't know because, like I said, there is another class that we have clashes with. So he asks for our free time as well, and he will pick a time that's suitable for him. So we don't know
Okay,
when.
all right. So I guess we'll just do this one class for this week, right? And you guys get back to me with the time, right?
Okay.
When
No
the
problem.
odd lecture figures it out, you get back to me with the time. All right.
Yes. Thank you.
So we get started out. All right. So this course is called ELE 2218, I think, right? So the name is Introduction to Microprocessors and Microcontrollers. The main objective of this course is to make sure you guys can program microcontrollers to build simple projects, okay? Interact with them, understand how they work, and maybe at the end of this course, build a simple project using a microcontroller, right? Has anyone in here done any programming before? Or maybe as collectively electrical guys, you did a programming course before?
Yes, sir.
What programming course did you guys do? The MATLAB one?
Yes, sir. We did that one.
Okay, so you guys familiar with like for loops, conditional statements, things like that, variables and stuff, right?
Yes, sir.
Good. So yeah, so I'll just briefly touch up on everything to refresh you guys because I know maybe some students don't remember programming good like that. So this here is just a brief introduction into Arduino, right? Which is the microcontroller board we're going to be using for this class. The reason I picked this one because it's pretty common, it's open source, and it's great for prototyping, right? Prototyping is just when you want to test the circuit out before you build the final design. And it's great for that because it's just a very simple development environment and it's easy to simulate. Now, alternatively, you can use things like PIC boards, Atmel, maybe ARM, Cortex. There are all sorts of different brands, all kinds of different microcontrollers and microprocessors that you can use. But this is the one I found that we could simulate easy. All right. I will maybe send you guys some theory on other types of boards, other things you can use, but I haven't worked out any way to simulate them, right? And given the fact that we can't be in the lab with boards or equipment to do physical work, this is the one we're going to be stuck with, right, for the most of the class, all right? So let me just introduce it. Right? Again, it's called Arduino. I'm going to start with what is a microcontroller? So a microcontroller is essentially a microcomputer. Think of it as a very little computer that has an internal processing unit, right? Let me see if I can start writing on this. An internal processing unit, some RAM, and some input-output interfaces, and is used for control purposes, and of course, data analysis, where we collect data from the world, right? So when we think about it, it has a CPU, RAM, some I/O, so it's kind of like just a mini computer. Now it's different from the computers we generally use with full-fledged processors, such as something like an Intel i5 processor, right? This is a full-fledged computer processor. And the processors in these chips, in these microcontroller chips, are very limited in terms of their functionality, right? So the general difference between a microcontroller and a microprocessor is just a microcontroller is more limited and more specific in its intended purpose, right? It's more for control purposes, whereas the full-fledged microprocessor that you would get in your computers and stuff are more intended towards multimedia purposes, running an OS, typing up Word documents, things like that, right? Additionally, not just processing power is limited, RAM is also limited, right? The RAM in these microcontrollers are very small, maybe a few kilobytes. The input and output interfaces, maybe just a few ports. And of course, they come in all different shapes and sizes. This is a very familiar shape, right? Remember that DIP package, right? Where here, where we just have a chip with two lines, right, of pins, and you can connect to them, right? Yeah. So some other famous microcontroller manufacturers are people like Microchip, Atmel. The Atmel is the chip on the Arduino board. So this here is the Arduino development board, right? And on it is an Atmel chip, right? On it here is an Atmel chip. Now we connect this chip using the Arduino development platform that allows us to easily just stick pins into the different ports, power the board by a built-on power supply, connect it by USB easily, right? And do all sorts of things fairly easily. So that would make prototyping easy, right? As opposed to just using a chip like this, where we'd have to put it onto a breadboard, connect it maybe via something like this. So we have to get a special connector, connect the chip up, plug it into our computer, open up the development software, type code into that, and load it onto the chip, and then take it back out and put it into our circuit, right? Okay, good. So instead of just using a chip like this, we use the entire development board, right? This is what the Atmega 328P looks like, and this is what the pinout is like. Right, so on the Arduino board, the Arduino connects the VCC, the ground, and that stuff up to the power supply. It connects these pins, all of these pins here, the 1 to 2 on the analog inputs and output pins, to the different these different female adapters here on the board. So it does that for us. So it makes it very easy for us to use, right? Okay. Yeah, Microchip is another good manufacturer. When I was in UG, we actually did programming on a PIC microcontroller, which is something similar to this, right? A PIC 16F, right? And we would connect to it using something like this. And then we'd go about building our circuit on a breadboard, right? Connecting the different pins to different, maybe a different LED or a sensor, right? And then connecting up the voltage up to the individual pins, right? All right, good. So now again, what is Arduino? Arduino is a microcontroller board. It contains an onboard power supply. So instead of us going to the individual chip, right, and running wires to supply power, it has a built-in power supply so that we can just plug it in and maybe plug it into a wall and power the board. it has a USB port to communicate with it, right? So that we don't need to go out and get something like this to plug the chip into to communicate with it, right? Yeah. So it simplifies the process of creating any control system by providing the standard board, the standard development platform that we don't need anything sophisticated to connect to, right? We don't have to do any kind of PCB design or anything like that. So we can use it for just start prototyping really quick. Now, Arduino is a company, an open source company, and they make a lot of development boards. And those vary depending on your needs. So there's the Arduino Uno, right, which has a basic number of inputs and outputs, right? Here's the Arduino Mega, which has more inputs and outputs. And this here depends on what your needs are. If you have more sensors to connect, more outputs to connect, maybe more LEDs, maybe you're developing an entire LED board, you might want to use a Mega to connect up. So it depends on how many things you need to control. So if you need more ports, you might want to go for a Mega as opposed to, there's also things like the LilyPad, which is used for wearable technology. Maybe you're developing, just prototyping again, just prototyping something like a smartwatch or something that really needs just a small chip with some simple inputs and outputs. You can use something like LilyPad or even an Arduino Nano, which again, just a few inputs and outputs and some digital signal processing capabilities. And again, a USB port to program it. So it just depends. Do you only need maybe one or two input and output pins? Do you need a few or do you need a lot? And they have like different boards for everything. And again, there are other ones with things like Bluetooth capability, Wi-Fi. If you want to connect to your phone, connect to a router, different things like that. And you just use that again, just for prototyping, right? Okay. So this is the one we're going to focus on, the Arduino Uno, right? Let me erase some of this stuff. As I was saying before, here it has the Atmel chip. This is the chip, this is the brains of the operation, okay? It has the USB port. And of course, some electronics for communication with the chip, right? This is going to connect to different parts of the chip and communicate with it, right? So from this USB, you're going to plug this up to your computer, and then you're going to load code onto the chip, and then the chip, you're going to interact with these inputs and output, right? Depending on what you have connected, right? Over here, we have our analog inputs, right? Analog inputs for analog signals. And we have here our digital inputs and outputs, the digital signals, right? And we know the difference between a digital signal and an analog signal, right? From last semester stuff. Again, here, this is the power input with voltage regulators here. So we can just plug this, use an adapter and plug this into the wall, right? So you plug our adapter in here. Then we can plug that into the wall and we can just power this board, right? Good. And we can take small amounts of power from the board as well to power our electronics. So maybe if you want to power something simply like an LED, you can take 5 volts off of it, right? And just send that to our LED. And we can power something small like that, right? Or maybe 3.3 volts and power something small like that, right? Now, if you want to power something bigger, maybe like a servo motor or something like that, you're going to have to do some external power circuitry for that, right? Okay. So again, as I was saying, the digital and analog signals, we know this from last semester, right? The analog are these continuous signals, things like temperature, right? Pressure, stress, elasticity, amount of light, right? Luminance, all these different analog qualities that are just continuous, right? And digital, we have things like just things that are on and off, very digital quantities. We have things that contain discrete values, so no values in between. This is a good example, the alphabet, right? We can think of it just having 26 possible outputs, possible outcomes, right? It's only A, can only either be one of the 26 letters, A or B, right? C, D, etc., right? So now, when we think about between A and B, there are no other inputs, right? So it's discrete. Between A and D, there are inputs B and C, right? But they're limited, they're discrete in number, so we can count them. 1, 2 between B and D. If you were thinking something like temperature, right? So between 0 to 32 degrees, there are like an infinite number of possible temperature values, right? In between, even between 0 and 1 degree Celsius, there are like an infinite number of temperature possibilities, things like 0 0.5, 0.25, and so on and so forth, right? And you can keep just getting smaller and smaller and smaller, right? And you guys know about infinitesimals from calculus, right? So continuous and discrete values. And depending on that, we're going to choose different inputs and output pins, right? So now another thing that we're going to need to connect up the boards are sensors, right? Sensors that convert the physical quantities into an electrical value or an electrical signal, right? Also known as transducers. In this case, this here is a light sensor. And based on the amount of light that comes into the system, right, we're gonna get a different voltage, right? We're gonna get a change in voltage or sometimes resistance. For sensors that use resistance, we might wanna use a resistor bridge, such as the very familiar Wheatstone bridge. We know in the Wheatstone bridge, we balance two sides and then we use this varying resistor to gauge how much this resistor varies based on this output voltage that we would measure, right? So depending on the sensor we use, we could have changes in voltage, changes in resistors, changes in resistance, and we build our circuits around that. And we use our Arduino to perform logic based on these changes. Simple things like, okay, when the sun goes down, the photo sensor, the light sensor is going to sense no light. So we can do the logic when the input current from the sensor is below a certain level, right? Then turn the lights on, right? When there's no light from sensor, on sensor, then turn light on, right? Turn light on. And again, with temperature sensors and things, when it's above 32 degrees, turn the fan on. When it's below 30 degrees, turn the fan off, right? And of course, different sensors, different values, photoresistors, photodiodes, transistors. There are also like thermistors and all sorts of different sensors. And we'll talk a little bit about them as we start using them for our projects. But again, there's a microcontroller course, right? Not a sensor course. Okay. So let's move on to the Arduino coding. So since you guys are fairly familiar with coding, you should be able to pick this stuff up fairly easy, right? Now MATLAB is what we refer to as a high-level programming language, right? High-level programming language. Now Arduino code, right, is based on C. Based on C, the C programming language. Okay, is based on C. So it's essentially a type of C, a modified version of the C programming language. And this is more of a lower level language, right? Lower level language. Now, the difference in between the two is that this communicates closer to the hardware. So you're going to find in MATLAB, you can do things fairly easily. You can just say X is equal to 13 and it creates a variable and it assigns the value 13 to that variable and it assumes the data type to be an integer, right? And it does things like that behind the scenes. Now, when you're coding closer to the hardware, because remember, you're writing code to be loaded onto a chip, and then this chip is going to use that code to execute and do certain things. When you're writing at lower level, and this is even more necessary if you try coding in assembly language, right? So below a lower level language, there's assembly language, which is even closer to the hardware. And then even below that, there's machine code. Machine code. This is the actual ones and zeros, right, that the machine uses to perform its logic. Right, so Arduino coding is a bit lower. So some things might not be as easy, but a lot of the principles carry through. Things like loops, right? So your for loops and stuff, conditional statements, if, else, these things carry through, right? And, you know, you guys are going to see. All right, good. So let's start off. So I'm just going to go through some basic things about the C programming language, right? So there's certain things called data types, right? So what's the data type? Well, when creating a variable, such as a variable X, in the C programming language, we need to specify what's going to go into this variable. Is X going to hold integers? So numbers like 1, 2, 3, 4, 5? Or is X going to hold something like a decimal, a floating point number, something like 0.23? Or is it going to hold a character, something like the character R? Or maybe even a string, right? Something like hello, right? What is this variable R going to hold, right? So in C, we need to specify that. And there are certain data types, right, with their accompanying keywords. So the first one is integer. Now integers are whole numbers, such as 1, 2, 3, 4, including negative numbers. So -1, 0 as well, 1, 2, 3, -2 as well, right? And it goes from 2 billion, about 2.1 billion, to -2.1 billion. So any number in between that, you can store using an integer. How we do that is we type int x. What this does, right, just int x, is it creates a variable called x with data type integer, right? Later on, we can then run a next line of code, right, that says assign x the value of 55, right? So this is going to go in to this variable x easily. Now in MATLAB, you would just do this, right? In the C programming language, you need to specify, right? You need to do int x. Alternatively, you can just combine these two lines of code and say something like int x is equal to 55, right? Another thing is you need to put a semicolon after every line in C, except for like function lines and certain special cases, right? But for the most part, you need to put a semicolon after every line in C. Now I know with MATLAB, a semicolon suppresses the output, but again, this is a lower level programming language, right? So you need to put a semicolon after every line. Okay. So another data type is character. So again, if you wanted to store something like the letter A or the letter R, you would do char, C-H-A-R, C is equal to R, right? Instead of being like C is equal to R, like you would do in MATLAB, you do char, C is equal to R. Creating some variable C that has the data type char, which refers to character, a single character, right? And it represents the value R. Now these values are represented from -127 to 128, and based on some kind of interchange code, something maybe like ASCII, that you guys are somewhat familiar with, it would represent a number which refers to this value. So with the compiler and everything, it's going to decipher what character this is, right? And you can do, for the most part, almost every character on your keyboard. Okay. So another variable type is long. Long. Now, a long is an extended size variable for the number stored. So with the integer, we were able to store up to plus 2.1 billion to negative 2.1 billion, right? But with long, what if we wanted a number that was bigger than that, right? Bigger than 2.1 billion for some reason? Well, we would instead type long, right? Long x is equal to some really big number, right? And of course, end with a semicolon. Now, the reason for this is because we're so low down to memory, we wanna, and memory and microcontrollers, again, is a very limited resource, right? We don't wanna create a variable, like create a variable x that can store really big numbers. So let's say we create a variable x and it could store a number that's above 2.1 billion, right? But we're using it just to store the number 2, right? What we're doing here is wasting memory, right? We're using a big 4 bytes of memory just to store the number 2. That's a waste of space, right? So that's why we separated to integer for like reasonably sized integer. And if you want to do something very big, then you go ahead and use long. Yet another data type is the floating point. This is for decimal stuff, so 0.0006. And we do this by using the keyword float. So let's say float decimal number. So you put denum or anything you want to name that variable, and you can assign it to 0.781 or something like that, right? Very simple. And again, always end with a semicolon. Good. So now different operators. Again, coming back to the coding, you guys know MATLAB, right? So you would do x is equal to 13. Then you would do m is equal to 14. And then you do y, some new variable is equal to x plus m. What you did here is use the addition operator plus to add 2 variables, x and m. Well, you can do the same thing with C, right? You can add variables together or even numbers together, right? And there are quite a few of them. There is regular math operators, right? So there's the addition, plus, put your 2 numbers on either end, right? There's minus, subtract, put numbers on either end. 2 minus 1 is 1, 3 minus 2 is 1, right? There's the asterisk that we use to do multiplication, right? There's the forward slash, right, that we use to do division. You can do something like 4 divided by 2, and that would give b equal to 2, right? Use this slash. This operator here is a bit different. The percentage sign, it doesn't refer to percentage, but what it is the modulo operator, right? Modulo. So how the modulo work? Let's say we had something like 8. The modulo operator, right? This percentage. Something like 8 mod 5. That would get evaluated to 3. How this works is what it does is it divides the number by 5 and it takes the amount of remainder left and it outputs that. So dividing 8 by 5, what we get is 1 with a remainder of 3, and that's what it outputs to 3. Now, you might be wondering, why would this operator be useful? Well, it's useful for many things. Let's consider maybe we're programming a clock, right? And we're programming a 12-hour clock. And in that clock, remember we're building a smartwatch. Maybe we're using our lily pad and we got some kind of digital display, maybe 2 7-segment displays, and we're designing a digital clock, right? So now the time in Guyana right now is 11. It says 11 o'clock, right? And the person wants to switch time zones to maybe somewhere in Australia, right? So now the time difference is plus 5 hours. Now we wanted to just do math and be 11 plus 5, but that's 16, right? 16 hours, right? But now if the person wasn't using a 24-hour clock, right? Not 24 hours, not 24. Let's type not a 24-hour clock. They just wanted a regular 12-hour clock. What we can do is take this number 16 and take the modulus of it with 12. So 16 mod 12 is going to be equal to 4 hours, which is the actual time that we want to display. So this branch here, this modular mathematics that we can use, if you want to do any kind of modular mathematics for cases like these, you can use the modulo operator. Similarly, for 24-hour clocks, let's say it was 23 hours in the middle of the night, and we want to increment maybe plus 4 hours from that, it's going to be something like 27 hours, right? But we want to mod that by 24 so that we know it's actually just 3 o'clock in the morning, right? So that there is a modulo operator, this percentage sign. Now this here, this up thing, something like 4 to the power of 2, right? In the C programming language, that doesn't exist, but I think for the Arduino modified programming language, it does. So if you're gonna code regular C, you won't see this up arrow thing, right? This caret. But in modified Arduino, it can come up, all right? Now logical operators, things like and or. So we can do statements, right? Like if A is greater than B and B is greater than C, then execute some code here, right? So we can do logical operations like that using this symbol, the double ampersand, so that if this here evaluates to true and this evaluates to true, then we can execute some code. And this is essentially the same thing as doing an AND gate. All right, good. Now there's another one. This two here. Line. This is for OR operations. So it works just like the OR gate. If this is true or this is true, then execute some code, right? Now this symbol is under your backspace key, so you can press shift backslash. It should be there somewhere, right? If you have trouble finding it. There's also not equal, which works like a NOT gate. Equal, which is just like a straight through gate. If like it essentially compares if A is the same as B, so this is like an XNOR gate, right? If A is the same as B, right, then execute some code and we can write code based on these logical operations, right? And the comparison operators, right? If both of them are equal, if A is greater than B, like what we did here, less than, if A is not equal to B, we can do that as well. Right? We can do A not equal to B. How we do this is exclamation mark equal. If A is less than or equal to, more than or equal to, and those are these, right? Now, some other things we use, again, the semicolon, remember I said, almost every line in C, every basic line like these, right, we end in a semicolon. We use curly brackets to end close code of functions, right? Curly braces to enclose the code in functions. We use these slashes, these are forward slashes, 2 of them for single line comments. So in MATLAB, you guys would use, I think, the percentage sign. So you'd use percent and then you type stuff. Maybe you type your name, the date, what this code is about for comments, or maybe you use like the hashtag, right? The ampersand to type comments. So that's what this single line comment is. When I show you start writing some code, you guys are going to see what this is. And then this here is for multi-line comments, right? Good. So far, you guys following? And does anyone have any questions?
Yeah, following, sir.
All right. Okay. So now it's just some more stuff about C programming language. Then we're just going to do a very small program, and then we're going to call it today, right? It says bear with me while I go over some other statement operators. All right. So now there's some compound operators like the increment. So we can just execute, let's say we created a variable I. We can say int I is equal to 0, right? And we had some code here, some code. And maybe we're doing a for loop, some sort of loop, right? Some kind of loop. And this code is going to execute all the time. So, and that's going to execute based on some conditions. So we can say something like, while I is less than 25, right? Execute this code. So I is 0 and we're working. Inside this loop, we can put I plus plus. I plus plus. What this does is it increments the value of I by 1. So in this case, I is equal to 0. I is equal to 0, right? And let's just draw a space in memory, right? The value 0 is going to be stored, right? And this here is your variable I. After executing this code here, I plus plus, right? This value is going to go up by 1. So it's going to change to 1. And if we run it yet again, it's going to increment to 2. And if we run it again, it's going to go up to 3. So it's just going to increment. And if we do minus minus, it's going to decrement. So it's going to move down from 2 to 1 to 0 to negative, right? That's a decrement loop. So we can use this for loops, saying, okay, let's just say I is equal to 0. And every time you run some piece of code, right, we increment this, right? So then this would keep incrementing, and when it reaches 25, it would come out of this loop, right? Very basic thing. So we can write some code that would execute 25 times or just a few times, right? Or we can additionally use it to keep track of stuff, right? We can say maybe we have a door, some door, right? And we have an infrared sensor set up across this door, right? So every time a person walks through this door, they trigger this sensor. So what we can do is we can set up code to write, okay, every time someone passes the sensor, increment the value I. We can change that variable from I to something like int number of people or people, right? And we can use this code to keep track of the number of people inside of a room and different things like that, right? Okay, good. We can also do things like compound addition and subtraction. Maybe we don't want to increment by 1, maybe we want to increment by 2. We can do something like I plus equal to. What this is going to do is going to take the value of I and add on 2. We can do I minus equal to, and this is going to continuously subtract the value of 2, right? Of course, you always need to end with semicolons. Compound multiplication, right? So you can do I plus a plus. I asterisk equal 5. And what this is going to do is going to multiply the value of I by 5, right? And the same thing with division, multiply the value of I, divide the value of I by 5, right? And these are just compound, really quick versions to do something like this. If you were to have to write this out, you'd have to write something like I is equal to I plus 5, or I is equal to I times 5, right? So this is just a really short way to just do compound division multiplication up, right? Okay. Now these kind of statements you guys are familiar, right? The control statements, if, conditional statements, if else. So we want to just execute some code based on a particular condition, right? If a certain value is true, right? If A is equal to B, right? If temperature is more than 32 degrees, then do something, execute some stuff. Else, if it's not more than 30 degrees, if temperature is less than 32 degrees, then do something else, right? Maybe you want to do something else when it's less than 30 degrees. Maybe here you want to turn on the fan, here you want to turn off the fan. Else, if it's not any of these things, maybe you have different things for maybe volume, right? Volume is equal to 32 psi, and volume is equal to 30 psi, right? And you have different conditional statements, but it's not 32, it's not 30, it's something else. You want to execute some kind of default statement, right? You can do that. So if, else if, else. Another thing is a switch case. So this is like, which one is it equal to? So maybe you have something, someone's pressing on a button, and they press a button, they press the button, right? And you store that value into a variable. They press the button 5, you store the value 5. And use a switch case, right? If the number is 1, we're supposed to do something. If it was 2, we're supposed to do something. If it was 3, we're supposed to do something. 4, 5, 6, 7, we're supposed to do something, right? When this variable is equal to case 1, is equal to the value 1, then we execute some code. Or if it's equal to the value 2, then we execute some code. This is different. I don't think this is in MATLAB, this switch case, but essentially just like a step through, like an else if. Different cases, whichever one is equal to, that's the line is going to execute. And then there's a default. If it doesn't match any of these cases, then we just do this default option, right? Maybe display number not recognized, out of range, something like that. All right, good. Now your loops, which you guys are familiar with, there are 3 types in C. The do while. So what it says is do, and you can see the curly brackets coming into play here, right? Notice the curly brackets don't need to end in semicolons, right? Because they just enclose the code, right? So what it says is do this piece of code while this condition is true. So what's going to happen is it's going to execute some code first while maybe I is less than 25, right? Right. And then in here, you can also have your I incrementing to do this thing 25 times, right? The good thing about this is that you know the code will execute at least once. It's going to do this at least once, and while this condition is still true, it's going to continue to do it. On the other hand, with the while loop, not the do while loop, different one, the while, it checks first whether or not the condition is true. So while this condition is true, then do some statements, right? Do some code, right? Good. So that's different. So this one, the condition has to be satisfied first. This one is going to do it whether or not the condition is true at least one time, at least once. And for, which is the loop most people use, right, has a lot of control parameters in it. First, we can set up some kind of variable. I, we can assign it to 0, right? And we can say when I is less than or equal to some value, this could be 25 in this case. And then every time we run this statement, increment it. So the for loop is kind of a compact way to do everything we might want to do in a loop. So we might want to create a variable to keep track of things. We might want a condition, and we might want some kind of compound addition, some kind of incrementation, right? So it allows us to do everything we might want to do. So for these statements here, these conditions here, execute these lines of code, right? For a very tight range, right? So that's your for loops. And that's it. Now, let me just give me like a few seconds. Let me just go get some water and then come back, right? So we've covered everything, well, almost everything that we need to know about the C programming language. So let's talk Arduino now. Now, in a perfect world, if we weren't on lockdown, if we didn't have COVID restrictions, we'd be in UG, we'd be in the lab. We'd go to Mr. Benjamin, right? And we would collect an Arduino board, right? Maybe an Uno or a Mega, whatever they have in the lab. We would take it. We would take the USB part, USB cable. We would plug it into our computer. Let me see if I can get some imagery up. Okay. Okay. Yeah, maybe something like this. Yeah. We'd collect an Arduino board, right? We'd plug it up to our computer. We'd run this cable to our computer. We'd connect up circuitry, maybe an LCD, maybe some LEDs and stuff. We'd write code on our computer. We'd load it onto this board. And then we let this board execute that code, maybe display this thing on this LCD panel, on this LCD display, right? But since we don't have that, we're gonna have to do simulations. But if we were to do this, first we'd get the board, we'd plug it up, we'd connect it to our PC. We'd go to arduino.com, arduino.cc, I think, but .com, I think, reroutes you to this site. We come here and we click software and we download the Arduino IDE and we'd install it, right? Whatever operating system you're on. If you're on Windows, if you use Linux, maybe Ubuntu or Arch or Mac OS, so whatever operating system you're on, you download the IDE, right? The install, you'd have some icon on your desktop. You double click that. It would load, it would open up, and you'd have the Arduino IDE, right? Right? You come in here, you type up whatever code you want to type, whatever code you want the board to execute, right? And then you would send that, you'd verify, click verify. Of course, it's not going to verify, right? And then you would upload that to your board. And then your board, based on how you wire up it and plug up the circuitry, would execute that code, right? But we don't have that going on right now. So we'll have to do some simulations, all right? Good. So now the very basic setup of any Arduino code. Come in here, we go file, new, file, examples, basics, bare minimum. Right. Bare minimum. So the bare minimum of any Arduino code involves two functions, setup and void loop. Here's where you put the setup code. Now, the way microcontrollers work, the way this Arduino works, is that it's continuously runs code, right? If it says display this, it's going to continue to display that. It's not going to stop displaying that. If it's programmed to blink an LED, it's going to continuously blink an LED as long as it has power. So that's why we have to separate these two. Void setup is for things you want to do at the start of the program and you only want to do once. So things like you want to set some pin as an output, right? And set another pin as an input, right? Code like that. I'll go through the specifics of how to do that. This is what you would do in this setup area, right? And what you would do in the loop, right? Maybe you want to try blinking an LED. Turn LED or send power to pin, send power to a pin that the LED is connected to, then disconnect power from pin, right? And then because this is a loop, void loop, and this is the basic setup, this is something that every Arduino code has, void loop, it's gonna send power to that pin and then disconnect power from pin. And it's gonna do that repeatedly. So what's gonna end up happening is that the LED is gonna turn on and off, on and off, on and off. Right? So back to our slide. All right, good. So the basic code structure. The two main functions, void setup and void loop. Void setup is used to indicate the initial values of the system on starting. So those basic things, assigning different pins as input pins and output pins, which pin you want to collect data from, different things like that, right? If you want to create some constant, something that's present throughout your code, you can do it in void setup. And loop contains the statements that will run whenever the system is powered after setup. Right, so that's the code is going to continuously keep running, right, over and over and over. All right, so let's look at the LED example. Good. So again, if you don't have to write the code, you can. It's fairly simple, but you can just come File, Examples, Basics, and just blink, right? That's the blink code. So again, those two basic functions, right? Void setup, this is where you put your setup code, and void loop, this is where you put the code that runs, right? So, actually I shouldn't have delete this stuff at the top. So here, because there's an Arduino example, they have multi-line comments, right? See that asterisk and that / that I was talking about comments. This isn't code, this is just stuff about the program that the compiler is going to ignore, right? So all that stuff in here. This is just program, turns an LED on for 1 second and off repeatedly. And this is here, it's just describing Arduino boards and gives you some link, right? And this here is a single line comment, right? That comments only this line. So everything after this is, the board is going to be like, okay, this is just a description. This is just a comment. Don't execute that, right? But only for this one line, multi-line, right? Think of it as like an open bracket here and like a closed bracket here. And everything in between is considered a comment, right? And this here is single line, which is just for this line. All right, good. So in void setup, let's leave this stuff now. See, you get this bigger. Okay, good. So in void setup, right? This here is a comment. This here is a comment. Let's delete this. So in void setup here, open parentheses, close parentheses. We'll talk about functions in another class. And then your curly brackets. And inside that, we have one line of code. Pin mode, LED built-in, output. Right? Good. So what this one line of code does is initializes digital pin, some pin called LED built-in, as an output. Now what we're going to do is we're going to change that pin to 13. Yep. And we're going to set pin 13 as an output. 13. So on an Arduino, here, right? There are different pins and different numbers, right? So we're setting pin 13, which is this pin here, as an output, right? So that pin, we want to be able to send voltage through it, right? Turn things on, turn things off, right? So we're setting it as an output. That's what this one line of code does. Pin mode, let's delete that. Pin mode 13, output, right? Now for the loop, right? It runs continuously, right? Got 4 lines of code. Digital write, LED built in. We want to change that to 13. We want to write a high to it. So what this is going to do is going to send a high value to that pin number 13, right? To turn the LED on. It's going to delay 1000. This delay function works in milliseconds, right? So if we type 1000 into it, it's going to delay 1 second. So it waits for a second, then it digitally writes back to the pin again changing this to pin 13, it writes a low. So it's going to turn the pin on, send the voltage out high, going to wait a second, send the voltage out low, then it's going to wait another second, right? And then this here is going to loop back around and turn the pin back on high. The reason it waits a second here is because if it were to turn this low, right, and then be looped back right around, back to high, it's just going to turn on back. So this here is the pin isn't going to stay low for long enough so that we can see it flash. We need this 1 second delay to see that the thing turns off, right? Because if we continuously turn an LED on and off, on and off, on and off, right, it's just going to look a bit dim. We're not going to be able to decipher whether it's on or off at like discrete points in time, right? So we need this 1 second delay. So let's look at that in an actual circuit. So for this class, you guys are going to use this site, do some simulation, right? Okay. Resistor. Good. And we're doing this simple Blink project. Right now, I'm going to send you guys this PDF. It has everything, has the little circuit diagram so that you can do simulation, has a schematic diagram so that you can look at, right? And it has some brief explanation in each line of the code. So I'll send this to you guys, of course, right? Good. So you're going to come to this site, tinkercad.com. Let me put it in the chat. Right. You're going to sign up. You're going to create an account. Then you're going to click circuits on this side, right? And you're going to click create new circuit. And it's going to take you into a page like this. And from here, you can search components. You can search for an Arduino board. you're gonna just drag that out. You can search for an LED and a resistor, right? So this here is simulating the process of actually being in the lab and making the circuit, right? So let's look at the circuit diagram. Let's look at the schematic, right? So here for the schematic, we know the Arduino board takes care of everything. Takes care of all this V and stuff, right? All the other things that we might need, right? So all we need to do is set up this LED. And of course, we need a resistor to limit the current, right? For the LED. Okay. So you want to set up pin 13 going to the cathode of the LED, right? Then the anode to ground, right? Good. So here, can I zoom this? Maybe. Okay, good. So this here is our LED. We want the anode going to 13, pin 13, right? See here, pin 13, and the cathode going to ground. Of course, on the Arduino board, see on this side, right? There's ground here, right? And there's of course 5 volts here if you might need it in the future. And these are analog pins, right? And there are other pins. You can change the number of the pin from 13 to 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? Good. And this pin is here. Now let's leave the resistor out for now. And now we need to put some code. So from here, you're going to see code, some blocks come up. I want you to switch blocks to text, right? Where you can type the actual code out, right? So here's the code already typed out for us. Pin 13, we set that as an output, right? We're writing 13 high, then we wait for 1 second or 1,000 milliseconds. Write low, wait. We're good. So now let's just start the simulation. The code is already there. We know how the code works and see what happens. So what happens, you see the LED turns on and off. Of course, there's some sort of disclaimer, and that's because the current isn't limited by this resistor, right? So we know that this resistor needs to be inside the circuit. Okay, so let's stop stimulation for now. Where does the resistor go? Well, the resistor goes between the D13 pin and the cathode of the LED. So let's put that in. Here. And now let's start this. Say 220. 20. Yeah. And now it's blinking. It doesn't have that warning anymore. Actually, let me stop this. I think this. Yeah. Okay. And now we're running. And we're blinking this LED. So that's basically it. I think this is a good simple example for the first class. We're connecting upper LED to our Arduino board. We're blinking it. We're using this very simple code. It's like maybe 10 lines of code. These parts are negligible, void loop, void setup. So like about 5 lines of code. And we're blinking an LED from the digital pin 13. Now for next class, we're gonna build on this example and we're gonna do more code. Of course, I'm gonna explain as we go about, but I think you guys should be able to do this yourself. So do you guys think if I sent you this PDF, you can go to Tinkercad, you can create a circuit, you can drag your Arduino board out, you can follow this schematic, right? You can build it based off of this schematic and this picture as well, right? You can build this circuit and execute the code, right? You guys think you can do that?
Yeah. Yes, sir, we can do that.
All right, good. So, all right, so that's gonna be homework for this class, right? Let me see if I have anything else planned. No, we talked about the Arduino IDE. So again, the reason we don't use this IDE, this is a desktop application, and this here, right, is online, right? It's some online simulation on Tinkercad, right? This we would type the code up here and we'd load it onto our physical board, but we can't do that. So you do simulation. And this is good software because if you look over here, right, over here, if you click stop simulation, it's like plugging out the USB cable and start simulations, like plugging in the USB cable to load the code up. And you can type the code up here, right? Okay, so that's it. That's it for first class. Simple example, blinking an LED. Of course, we're gonna do way more complicated projects and have all sorts of different things connected up to our microcontrollers. We're gonna go through a lot of theory. We're gonna look at what's actually inside the chip, right? I'm gonna send some handouts for you guys to read. We're gonna have some assignments along the way, some little projects along the way, and hopefully we learn something, right? All right, good. So for homework, do this example, do the blink. I'll send this PDF. You guys have the textbook, right? Did everyone download the textbook and take a look at it?
Yes, sir. We got it.
All right, good. And inside the textbook as well, there's some stuff on this. All right. So that's it. That's all I have for you guys for today.
Sir, one question.
Yeah. Okay.
Relating to the timetable, can we move Thursday class to either earlier in the day or to Monday?
Thursday class, the early in the day. How early? Like 10?
Yeah, 10 to 12 would be good.
All right. Yeah. Good. I think Vladimir Goberdan, I was talking to earlier. Yeah. So you guys just set yourselves on a time and then tell me, and I'll schedule classes for that. All right. So tomorrow class, you want to do a 10? Actually,
Yes.
let's just have a next class next week, Wednesday, right? And then we'll move forward from there.
No problem, sir.
All right, good. Good, so yeah, that's just it. Just do this circuit, do the simple program, make sure you understand the program. And then next week, we're gonna do something more advanced. All right, thank you guys for coming. Hopefully you learned something. All right, good, that's all.